Okay, hi guys, it's Ian here from Crack Maths and welcome to today's live math session. Today we are covering the topic of compound measure, okay? Compound measure. And what this means is this is like when we have a few calculations that are all commonly linked together. So one of the ones that we have is speed equals... Today we are covering the topic. All good for sound. Speed equals distance over time. And then we also have density equals mass. No, density is grams per centimetre squared. So it's mass over volume. And the other one we have is we have hourly rate, which is often discussed. So your hourly rate is usually going to be your pay over how many hours you've worked. So the amount of money, in fact I'll say money, so yeah, your money, oh my gosh, money per hour. Okay, let's take a look at what some of these mean really, because it's easy to look at these formulas, but actually sometimes it's actually easier often with these questions just to look at the questions, because these formulas they're not difficult to remember, but remembering any formula is quite hard. But actually with these formulas it is often easier just to think about what they truly mean. So for example, if we think about speed, this says distance over time, but you're going to know some speeds, okay? One of the most common speeds we know is miles per hour, okay? And that's miles per hour, or per, it might be like this, miles hour, okay? And when we say per, miles per hour, that means kind of like miles divided by hours, which is the same as distance divided by time. Density, the volume units for density that we often get are grams per centimetres cubed. Okay, so again, this is grams, so this is the mass, and centimetres cubed is the volume. And hourly rate, you often know that someone might earn like £12 per hour or something like that, £12 per hour. Okay, and again, this line, this per line, this does mean divide. Okay, so let's actually just get cracking with some exam style questions on this, because I don't want to focus too much on the formulas. I want us to kind of think about how this stuff works. Okay, so I'm going to move over here and let's go to some exam paper questions. Again, I think I've mentioned these in some past tutorials, but these exam paper questions, I get them from a site called Mars Academy. Mars Academy. I think it's .com or .co.uk. Try both, it's one of the two. But basically there's somebody that's put together all of these sheets, exam paper topic by topic by topic by topic, and they've done a brilliant job at just going through loads of past papers to get together these things. So let's have a look here at this first question that I've got. This is from a City and Guilds exam paper, and this is the non-calculator section of this sheet. So let's have a look at what they say and see if we can work this out together. So it says here that a woman needs to work out how long it takes to drive to York. She checks the whole journey on the website, and the distance from her house to York is 80 miles. 20 miles of the journey are through roadworks with a speed restriction of 40 miles per hour. She should give the rest of the journey an average speed. She should drive the rest of the journey at an average speed of 50 miles per hour. How long should the journey take? Right, okay, so what we have to do here is we really have to break this down first to work out what the question's asking us to do. So we can see that we've got some numbers. The whole journey is here, it's 80 miles. And then 20 miles of the journey are through roadworks at a restriction of 40 miles per hour. Okay, right, so I want to think about this I'm going to think about this speed that we have. 40 miles per hour means in 1 hour they're going 40 miles. So I'm actually just going to write it out like this. 40 miles per hour means 1 hour is 40 miles. That's what 40 miles per hour means. And I can see that 20 miles of the journey are through roadworks of this speed. So I know that if in 1 hour that'd be 40 miles, I want to find out how long it'd take to do 20 miles. Now I can see that 40 divided by 2 is 20. And I know that 1 hour, well, divided by 2 is going to be half an hour. So that's going to be 30 minutes. Right, so we know that 20 miles is going to take 30 minutes. So that leaves 60 miles left. So I'm just going to make a note here. We're looking at 60 miles left. Now, we're told that she should drive the rest of the speed at 50 miles per hour. So that means in 1 hour, she does 50 miles. So I'm going to write that down here. 1 hour is 50 miles. Right, okay, so, well, in that case, if she's got 60 miles, I know that 50 of them are going to take 1 hour, okay? So we're then just looking at the last, so, 1 second, I'll bank that over here. So we've got 30 minutes, that's for 20 miles. We've got 1 hour for 10 miles, no, for 50 miles. And then we've got 10 miles left, okay? So again, 10 miles left is at this 1 hour is 50 miles. So what I'm going to do is I'm actually going to switch this round. I'm going to go 50 miles is 1 hour. But I'm going to change this hour for minutes. So I'm going to call this 60 minutes, okay? So if 50 miles takes 60 minutes, well, I want to know what 10 miles does. So I need to divide this by 5. So if I divide this by 5, that's going to give me 10 miles. Okay, and then if I divide the 60 by 5, 60 divided by 5 is 12 minutes. Okay, so now I know that 50 miles she does in 1 hour, 20 miles she does in 30 minutes, and this last 10 miles here, she does in 12 minutes. So now what I can do is I can collect all of these together. Now, remember, I haven't actually used any formulas here, I haven't had to remember anything. All I've focused on is my interpretation of MPH, which means miles per hour. It means how many miles in 1 hour. So let me finish this off then. So I've got time taken is 1 hour here, and well, 30 minutes add 12 minutes will be 42 minutes. So the answer to this question would be 1 hour, 42 minutes. Okay, let's move on to another question. Remember, if you want me to go through anything or you've got any other questions, please let me know in the chat and I'll stop what I'm talking about and we will go through your questions that you have. So that's absolutely fine. So let's have a look at this second question. Okay, so I'm just going to have a read through it here and to see what that says. And so what I can see, sorry, I feel like I should look at the camera more, but the thing's on the table, so it's difficult to read and look at this. So here we go, we've got, you are planning the delivery of furniture to 2 customers. You expect that you will drive an average speed of 50 miles per hour. So again, we know that 1 hour is going to be 50 miles. That's what 50 miles per hour means. Unloading each delivery will take 30 minutes. This is the route that you will take. Okay, so I'm assuming we start at the depot and then we go to delivery 1 and then we go to delivery 2 and then we'll go back to the depot. You leave the depot at 8 a.m. Okay, I'll make a note of that. 8 a.m. here. What time will you return to the depot if everything went to plan? Okay, right, so we need to get some information. So this bit is 55 miles. So I know that 50 miles takes 1 hour. Okay, so 50 of those miles will take 1 hour. So what I need to do is I need to work out how long the extra 5 miles will take. Okay, so I'm going to convert this. I'm going to actually switch this round to put the 50 miles here. And I'm going to convert the hours into minutes. So 50 miles will take 60 minutes. 60 minutes. Now, I want to get 5 miles. So what I can see is I know if I divide 50 by 10, okay, I'm left with 5 miles. So 5 miles here is going to be 6 minutes, because 60 divided by 10. Goodness me, my writing's awful today. 6 minutes is that. So this 55 miles will take 1 hour, because it's 50 miles in 1 hour, and then 6 minutes. So that's 1 hour and 6 mins. Okay, right. Delivery 2 is 110 miles. Okay, well, the journey to get from delivery 1 to delivery 2 is 110. Now, I can spot that 110 is 2 lots of 55. Okay, 55 multiplied by 2 is 110. So if I know that it's 1 hour and 6 minutes to do 55 miles, if we're going the same speed, we're still going the 50 miles an hour, that means that this journey is going to be 2 hours and 12 minutes. Okay. Right, now we've got this last journey here. Now 135, sadly, isn't a multiple of 55. Oh, but what I can see actually is it's 25 miles more than. So if I look at here, this is 110 miles. 135 miles is 25 miles more. So if I know that 1 hour, well, or 60 minutes, 60 min is 50 miles. If I divide both of these by 2, I get that 30 min will be 25 miles. Okay? So that's a useful thing, because now what we can do, if we know that that extra 25 miles is going to take 30 minutes, we can simply add 30 minutes to this time here and get 2 hours and 42 minutes. Okay, so here we go. I'll put 2 hours, 42 minutes here. Okay, right. Now, we know that each delivery unloading will take 30 minutes. So we've got to add 30 minutes here and 30 minutes here. Well, and those two together will make up 1 hour. So what I'm going to do is I'm now going to add all my information together. So I've got 1 hour, 6 minutes, 1 hour, 6 min, plus 30 min, plus 2 hours, 12 min, plus 30 min, plus 2 hours, 42 min. Okay, right, so I know that these two make up an hour, okay? So I'm just going to cross them out there and put plus 1 hour, because that's easier. So I've got 1 plus 2 plus 2 plus 1, which makes 6 hours. Then I've got 6 plus 12 plus 42. 6 plus 12 plus 42. Actually, that makes up another hour as well, because 6 add 42 is, well, 48. And then 48 add 12, add on the 2 is to 50, add on the 10 is to 60. So that equals 60 mins. Okay, so the whole trip is going to take 7 hours. Okay, and the question is, work out what time should you return. So 8 add 7 equals 15. Okay, so that would be 15 o'clock, which we could write as 15 o'clock, or as we could write as 3 p.m. 3 p.m, 1500 hours. Both of those would be fine. Okay, great. So that is another compound measure question. Right, what I'm going to do is I'm going to find here we go. This is one that I wanted to do. I wanted to have a look at this because this is a volume density one. Now, the principle is always pretty much actually the same with these. So even though this is no longer speed, distance, time, this is mass, volume, density, it's going to, the way that we're going to solve it is going to be similar. But let's have a look here. So, right, let's read through the question and then I'm going to point out the clues to how to solve density questions. So Jack is a jeweller. He makes a pendant in the shape of a triangular prism as shown in the diagram. Jack makes the pendant from solid gold. He uses this formula. Volume equals T times L. Okay, well TL. Remember, if you ever see a formula, that means that with letters written next to each other, that means that we're multiplying those together. So I'm going to write down here, volume equals T times L. Okay, so the V stands for the volume, T stands for area of the triangle face, and L stands for the length of the prism. Jack knows that mass equals density times volume. The density of the gold is 19 grams per centimetres cubed. Okay, so let's just focus on that a second. 19 grams per centimetre cubed. So that means that every 1 centimetre cubed equals 19 grams, okay? And this is the real key point to any compound measure question. It's picking out what 1 unit is going to be worth. So we know that 1 unit, 1 centimetre cubed of 1 centimetre cubed of the gold gives us 19 grams. That's what that means. 19 grams per centimetre cubed. So every centimetre cubed is 19 grams. So we also know here the cost of 1 gram is £40. Okay, so this is going to be a double question here because we've got, well, obviously we've got more to it. And it is worth 6 marks, so there's quite a lot to go on. But remember, with these questions, they are really just lots of small questions pieced together. We just have to kind of get through it all. So Jack sells the pendant for £382 more than the total cost of the gold needed to make the pendant. How much does Jack sell the pendant for? Okay, so first things first, we need to work out the volume of this triangular prism, which means first of all, we need to work out the area of this triangle. So area of a triangle is a formula that you need to know, and it's base times height divided by 2. So in this case, it's going to be 3 times 1 divided by 2, and that equals 1.5. Okay, or we could keep it as 3 over 2. I think, well, let me leave it as 3 over 2 for the time being. It doesn't really matter either way. But now that we've got it as 3 over 2, we then need to times it by the length, because here we go. The volume of the prism is the triangular face, which we now know is 3 over 2 centimetres squared, times the length. So we're looking for 3 over 2 times 4. Now, whenever we multiply fractions together like this, what we do is we have to remember that every number is secretly a fraction over 1. We just don't bother writing it because it would just be cumbersome. So, but whenever we have to multiply fractions, it's useful to remember. So now we're looking at 3 over 2 times 4 over 1. With multiplying fractions, we do the top times the top and the bottom times the bottom. So that's going to equal 12 over 2, which will equal 6. Okay, so now we know that the volume of this triangular prism is 6 centimetres cubed. Right, now, remember this. 1 centimetres cubed is 19 grams. So have a quick think about what we're going to do with this information, okay? 1 centimetres cubed is 19 grams. We know that the pendant is 6 centimetres cubed. And once we know that, we also know the cost of 1 gram is £40. Okay? So what we're going to need to do is we're going to need to find out how much does this weigh. So I'll just, let me just move this fraction work. Oh, didn't do a very good job there. Let me move this fraction work up over here, and I'll put it there. And so what we've now got is we've got 6 centimetres cubed is how many grams. So what we've done is we're actually just multiplying this by 6. Okay, so 1 centimetre cubed times by 6 gives us a 6 centimetres cubed. Remember, each one of those 6 centimetres cubed weighs 19 grams. So we need to do 19 times 6. Okay, well, I'm going to do this by doing 9 times 6 and 10 times 6. Okay, and that's going to give me the same as if I did 19 times 6. So 9 times 6 is 54. 10 times 6 is 60. So if I add these together, that's going to give me 411. So that's going to give me 114 grams. So I know that 6 centimetres cubed is 114 grams. Now, what we need to do is we need to think about how much this is going to cost. So I know that 1 gram costs £40. And then we've got here that we've got 114 grams. Right, okay, so what we've got to do is 114 times 40. Okay, so because we've times this side by 40, so we need to times this by 40 as well. So 114 times 40, oh no, that's 114 times 40. Well, what I'm going to do is I'm going to think about it as like this. 4 times 100, 4 times 10, 4 times 4. Okay, add that together, and then I'll add on a 0. So 4 times 100 is 400. 4 times 10 is 40. 4 times 16, 4 times 4 is 16. So if we add all that together, we're going to get 654. Oh, it's an expensive pendant. Right, so if I times all this... Oh my goodness, what am I talking about? Sorry guys, I've just gone completely wrong. I did not mean to say that 1 times 40 gives us 114 grams at all. I meant to do... Oh, we're still doing the right thing though. Sorry about that. I should have written times 114 here. Times 114. So we are still we've still done the right calculation, but I just wrote the wrong thing up there. I'm very sorry about that. If you do spot me doing anything like that, please feel free to let me know. I won't be offended. So we've got here, we've added these together. So we know that 40 times 114 is equal to 456, and then I'm adding the 0. Okay, so here we go. We've got this all done. Right, so the next step for us to do is Jack sells the pendant for £382 more than the total cost of the gold. So now all we have to do now is add on this 382. Okay, so 0 add 2 is 2. 6 add 8 is 14. 5 add 3 is 8. Add 1 is 9. And then 4. So the total cost of this pendant is going to be £4,942. Okay, great. Well, that's that for that one. I'll leave you just to have a quick look over that and just think about it. I'll be back in 1 second. Okay, right, sorry about that. So anyway, remember, if you've got any questions, feel free to ask. Otherwise, I will just now move on to another question. Okay, so, here we go, great. We've got another mass volume density question again. In fact, in this one, they've actually given us the formula. But again, as I said before, I don't really like to think too much about the formulas when it comes to these. I prefer to look at the unit, look at what they're saying, and try and think what that means. Because if we get het up on formulas, then we can really kind of lose ourselves a little bit. So let's have a go at this question here. So Nicola wants to put a flat roof on a bike store. The roof will be made of concrete in the shape of a cuboid as shown. Nicola wants to put a metal strip along two of the longest edges of the roof. Okay. She knows that the density of concrete is 2,300 kilograms per meters cubed. So remember, let's think about what that means. 2,300 kilograms per meter cubed. So that means that 1 meter cubed weighs 2,300 kilograms. Okay, that's what that means. The mass of 1 meter of metal strip is 5 kilograms. Okay, so 1 meter of metal strip is 5 kilograms. Okay, well, we'll think about that one a bit differently, but we'll remember that as well. So 1 meter of metal strip is 5 kg. Okay, I'll just make a note, concrete here and metal. So work out the total mass of the concrete and the strips she wants. So first of all, let's see what we're going to do. So Nicola wants to put metal strips along the 2 longest edges of the roof. So that's going to be this edge here and this edge here. So we know that that's both 3.5, each one's 3.5. So 3.5 add 3.5 or times 2 is equal to 7. So 7 meters is going to be 5 kilograms times 7, which will be 35 kg. Because we've times both of these by 7 because they're directly proportional. Okay. Right. Now, we need to know... sorry about that, that shocked me. So now we need to know the volume of this cuboid. Okay, so the cuboid is, well, to find out, it's like the prism really, but to find out the volume of a cuboid, we multiply all of the measurements together. But what's worth noticing with this is that this measurement here is in centimetres and the other two are in metres. So the first things we need to do is to turn the centimetres into metres. Now it's important to turn the centimetre into metres rather than the metres into centimetres because density is per metres cubed in this situation. So we don't want to veer away from metres cubed. We want to stick with the units that are littered throughout the question. Okay, so I know that there's 100 centimetres in a metre, and so I know that 12 centimetres equals 0.12 metres. Okay, and we kind of got that by just dividing by 100. So now what I can do is the volume of a cuboid is length times width times depth times height, whatever you choose to call it. So I'm going to do 2 times 3.5 times 0.12. Okay, length times width times height. Okay, so is this one still non-calculator? I feel like this should be calculator now, but they haven't said specific. Oh yeah, they've got a question too. Let's try and model through without a calculator, just in case it is non-calculator. So 2 times 3.5 is 7. So we're looking here at 7 times 0.12. Okay. Now remember, with this, with decimals, you can think about it like this. So this is actually like 7 times 12 and then dividing that answer by 100. Because 12 divided by 100 is the same as 0.12. So 7 times 12 gives me 84. And then if I divide that by 100, that equals 0.84 meters cubed. Okay, so here we go. We've got the volume. So density of concrete is 2,300 kg per meters cubed. Whew, Okay, right. I think I might have to whip out the calculator for this. I can't imagine this not being a calculator question, but let me just kind of bring this. Let's just scroll down to give myself a little bit more space. So we know that one meter cubed of concrete weighs 2,300 kg. Okay, so well, I guess we can do this. So that means that 0.1 meters cubed is going to be 230 kg. Now, if I times this by 8, I can get 0.8 meters cubed. So 0.8. So 230 times by 8. Well, that's the same as, we'll add the 0 on at the end, but that's the same as 200 times 8 plus 30 times 8. So 200 times 8 is 1,600. 30 times 8 is 240. Okay, so 0.8 is going to be 481. Okay, so 1840 kg. Now we need to work out 0.04. Okay, so because that's what we need to work out, the 0.04. So 1 second, but we know that 0.08 would be this divided by 10, 184. So 0.04 is going to be half of this, so that will be 92. Okay, so we know that 0.04 is 92 kg. So what we now have is we have here that 0.84 is going to be 1840 plus 92. So we add these together. 8 add 1 is 9. So there we go. So that's going to be 1932 kg. Right. Work out the total mass of... Oh, okay, that's fine. So it's just the total mass. So we're not going to have to do anything else with these numbers now. So we've got the mass of the concrete is 1,932 kg. We know the mass of the metal strips is 35 kg. So in order to get the final answer to this question, we're just going to have to add those together. So let's see if we can do that. So we've got, I'm going to do it down here. We've got 1932 plus 35. And all together, that's going to be 7691. So here we go, 1,967 kg. Okay, perfect. Great. I hope, really, for the sake of people taking the paper, that was a calculator question, but it was possible to muddle through it without a calculator. I just think it seems a bit mean. Right, let's have a look at what's going on next. Okay, so this is another speed, distance, time question, actually. So I can see here, it's also going to require us to use a ruler. But I can just fake that and we can all pretend that we've measured it correctly. So let's have a look at this question. In this one, I've seen this one before actually, it's quite fun. At 2040, a witness saw the suspect entering the park at gate A. So we're looking at a crime scene. Another witness saw the same person leaving the park through gate B exactly 12 minutes later. The group are given this map of the park. This map has a scale of 1 to 25,000, which means every 1 centimetre on this here, every 1 centimetre on this map is worth 25,000 centimetres in real life. Okay, so let's just say the centimetres. I'm going to create my centimetres here. I think these look like centimetres. I'm going to make it easy for us. I'm going to give us a whole number of centimetres. The distance between the gates on the map is 9 centimetres. I should have just read ahead. Right, let me get rid of that. There we go. The distance between the two gates is 9 centimetres. That's fine. What was the average speed of a person seen entering and leaving the park? Give your answers in metres per second, okay? So ms means metres per second. So that means how many metres per second. So we want to know how many metres. So 1 second is how many metres. How many metres are they going in 1 second? So that is the big question. So we know that the scale of this is 1 to 25,000. Now that's going to be 1 centimetre equals 25,000 centimetres. So what I'm going to do here is I'm actually going to turn this bit into metres. So every 100 centimetres is a metre. Okay, so what we're going to do here is we're going to do 1 centimetre equals 250 metres. Okay, remember you can divide by 100 by just knocking off these zeros. So that's all I've done there. Dividing by 10 knocks off 1 0. Dividing by 100 knocks off 2. That's if the number ends in zeros, obviously. So here we go. We've got 1 centimetre equals 250 metres. So now we need to work out what is 9 centimetres. Right, so we need to do 250 times by 9. So 9 times 250. Now remember, this can be split into 9 times 200 and 9 times 50. So 9 times 200 equals 1,018 and then 2 zeros, so 1,800. And then 9 times 50 is going to be 45, then plus the 1 0. So add these two together. We're going to get here, we're going to get 0, 5, 2, 1, 2. Okay, so we can see that this is going to be 2,250 metres. Alfred. Okay, so we've got here that we've got here that 9 centimetres is 2,250 metres, and we know that he took, how long did he take? 12 minutes. Okay, right, so 1 second, sorry guys. Come here. What? Okay, so we've got here that what have we got? Sorry, we've got that this is 12 minutes. Okay, so 12 minutes it took him to ride that. So we need to work out what is 12 minutes. So remember, our speed is in seconds. Our goal is to find how far he goes in 1 second. So if we know that currently it's 12 minutes, 12 mins takes him 2,250 seconds. No, 250 metres. Sorry, I've been thrown off here. Right, so if we know that 12 minutes is 2,250 metres, we need to get this into seconds. So, first of all, we need to go from minutes to seconds. So, 1 minute is 60 seconds. So that means that 12 minutes is going to be 12 lots of 60. So 12 times 60. Well, 12 times 6 is 72. And then I add the 0. So there we go. So 12 minutes is 720 seconds. Again, this seems like a mean question for a non-calculator question. But let me move this up here. And I'll just put that there to give myself some more space. So I've got here 720 seconds is going to give us 2,250 metres. So I can divide both of these by 10, which makes it a bit easier. 72s is 225. And so now what we need to do is we need to divide these both by 72. Okay, so 1 second is going to be 225 divided by 72. Wow, okay. This must be a calculator question. But let's work it out. So 72, 144, and then I'm counting up in 72s here to see what the whole number part is going to be. So we've got, because this is a top heavy fraction, 72, 144, 216. Okay, so this is going to be 3 whole seconds because we've got 3 whole lots of 72 in here, and then 225 minus 72, well, no, minus 216 is going to leave us with 9. So this is going to be 3 and 9 over 72. Now, I do know that 9 and 72 are both divisible by 9, and that's going to be an eighth. So this is going to be 3 and an eighth of meters per second. And I do know that an eighth is half of a quarter. So if a quarter equals 0.25, an eighth equals 0.125. So therefore, this answer is going to be 3.125 meters per second. Okay, again, very cruel if that's a non-calculator question, but I suspect because of this final calculation that it wouldn't have been. But it's always good to practice your non-calculator techniques. Okay, right, I don't think I've necessarily got time for another question today, so I'm probably going to leave it there. Well done if you've made it this far, and thank you very much for joining me. Remember, on Thursday, we are going through a past paper. It's actually a bit of an interesting one this time because it's an online past paper. So there's a link to the link in the description, which you can access, but I will be posting up the links for those live sessions shortly anyway. So if you've got any questions, remember, just feel free to write them down in the comments or whatever. And then, yeah, other than that, I hope this was useful, and see you on Thursday or Friday. Okay, great. Thank you. Bye.